hope I can get this to work. All right, can everyone see the screen? Francis, can you see?
Yep, we're all set.
All right, so thank you all for joining. Let's get started. So the exam breakdown of what the new test is going to look like. Part one, which we anticipate will be one packet that is handed over to your child on the test, will have the reading and the essay. It will be 70 minutes for reading and 40 minutes for essay. That is the information we were given. We do not know at this time if that means that together they have this time to work between the reading and the essay, or if they will cut it at 70 minutes for the reading and then 40 minutes for the essay. What that means that we should anticipate and how this is different is that the reading is a little bit longer than we had before, and the essay is a little bit shorter. We're hopeful that students can work along this packet and the time that they need and would be able to allocate a little bit closer to an hour per section, since we don't think that students need a whole 70 minutes for the reading usually, but could use that time more so for their essay. However, if that isn't the case, we also want students to be prepared for every possibility. So I've been working with my students to practice them having written their essay in 40 minutes, just in case. So I would recommend that students in their practice tests and their homework essays practice trying to get that essay time down a little bit, just in case this is the outcome. And then we have, as we talked about, a brand new math section, and that's broken down into quantitative reasoning and math achievement. Now, effectively, they're not distinct from each other in the types of questions that will appear or the math that is tested. The only real distinction is the quantitative comparisons that I'll show a little bit of later, which are not the traditional multiple choice questions that students are used to. But the quantitative section will have 37 questions in 35 minutes, and math achievement will be 47 questions in 40 minutes. Now, our anticipation is that that will be one packet that is given together, and students can work freely between the two sections. But like I said, because the math isn't particularly distinct between those two sections, there's not really an advantage to working on math achievement before quantitative, or that one is harder or easier than the other. They're fairly similar. But what that does mean that in total, we, for the math, have 84 questions in 75 minutes, which is a very, very big difference from what you've seen on the former 100 test. So the total here is 185 minutes, which is in total only 5 minutes longer than the 100 test. Now, I always do stress, and I know students have been studying for a while now, so they may be more used to this, but this is a 3-hour exam. Your child may never have taken a 3-hour exam before. This is hard. It's hard just to sit down and focus for these 3 hours under the conditions of testing. So it's something that we also want to practice and build up on, is taking practice tests or even doing their homework in one sitting. Maybe do it timed, maybe set limits to what circumstances they're in, just to get acclimated to those test day conditions, because that's really tough. Now, what does this mean? What do these changes show for us? Like I mentioned, for the ELA, we want students to be prepared to finish that essay in 40 minutes if they need to. We don't know, obviously, the prompt that's going to happen, but as you've seen, we have been practicing with a lot of the former prompts and similar prompts based off of that. And that kind of falls into two different categories. It could be the long format that's based off of like an open-ended question that we usually encourage students to write 4 to 5 paragraphs on, or it could be the short format, which is based off of either a poem, a passage, pictures, something like that, that directs students to answer 2 prompts in 1 paragraph each. Now, it seems like it's a little bit shorter. However, students' paragraphs are anticipated to be rather long. So at the end of the day, they could be roughly similar in length and require similar preparation, same outlining, descriptive detail, all of that. So students should be able to kind of go between the 2 different types of essays and be prepared in both scenarios. And regardless of that, and even given the shorter time frame, we want to make sure that students still allocate time to outline and still make sure that it fits in the space that is provided. So students will be provided, or at least historically have been provided, 2 pieces of paper that are lined, which are, the lines are wider than a traditional notebook. So it gives them a little bit less space than they may think they have. And so being able to fit your entire essay in those 2 pages is pretty critical. And that's not something that, we practice here with the practice test that students take at Kweller. I always remind students that handwriting counts. Now, I know a lot of students are writing their homework essays online and submitting them that way, which is perfectly fine, and I think a great way to practice and prepare for different topics and prompts they may experience. But on the day of the test, they will be handwriting. And if your child's handwriting is messy, that makes it difficult to read. The essays are read by real teachers. So you can imagine that there's someone sitting there for hours reading 500 essays and categorizing them. And I tell students that, if I'm 500 essays in and yours comes up and I have to decipher every word on the page, it just takes away from the, possible score you could be getting. So make sure it's legible, make sure it's clear. It doesn't have to be perfect, but as long as it's neat enough to be legible. Which is why I say practice handwriting, given that a lot of what students do nowadays is online. This is something that it tends to stay on paper. And I guess the other thing was about this being 40 minutes, right? We don't want that to take away from outlining time, but maybe think about how you can cut that down, try different strategies for outlining. I always ask students to, especially in their practice and in their homework, try different methods of outlining. See what works for you and what doesn't work for you. What helps you save on time as opposed to what makes you take too long if you're writing too much in your planning page. Students should still receive a planning page where they'll be able to freely outline, which will not be contributed to their grade or reviewed by the graders. So that's that. If there are any questions about anything, and I'm trying not to go too fast, you're welcome to ask questions in the chat and I will address them as we go along. Then to the reading. We anticipate that the reading will remain at the same approximately 50 questions as it has been in the past. However, in the past, we have given students about an hour to do so, and some have taken even less time if they wanted to spend more on the math. Now, we anticipate they won't be able to do that anymore because they will be split in the time spent on the ELA and the time spent on math. And the way we think that this would be done is that they'll be provided 2 separate packets, and one packet will be taken away before the second packet is given. So what this means is that likely students will have more time to spend on the reading, which can be good if students know how to make the best of the time. I know they're used to kind of rushing through questions and rushing through the passages and reading quickly. But I would also ask students, what would you do differently if you had more time? And simply rereading it another time or going back to the questions another time is not going to be effective if they don't know what changes they're going to make or what they will do differently. So this is a good time to review with students their reading strategies. Maybe it's more underlining, more annotating. Maybe it's making mental summaries. Maybe it's going to find evidence back in the text. Maybe it's notating the questions for the question type. All of the strategies that students have covered in their classes are very helpful, and they can be even more helpful if they can use them since they have more time now. So it's, I think, a great use of your review time is to go over these strategies and make sure that students can use them even when they have slightly longer time. We don't want students to end early and just have extra time on this ELA. We don't know if they'll be able to go back and fix their essay or move on to their essay. It could be that they have to sit with this reading for 70 minutes. And if that's the case, I want to make sure that students are using the most of their 70 minutes there. A good question from the chat, do students have to show or demonstrate they're working through the problem for the math and outline on the essay on a different page? So they will have so for the math, we'll talk about that in a little bit, but for the reading, they will have a planning page where they can outline and do whatever they want. I'm sure all of the Kweller classes talk about outlining strategies and how to make the most of that planning page. It will never be viewed by the graders. It will never be factored into the grade. So you can doodle on it if you want to, but we obviously don't recommend that because there's great uses that you can make out of that planning page and take 5 or so minutes to structure and plan your essay before you start writing. Um, that's another thing that I had a worry for students that they would think if time is cut on the essay, then that time should be cut on the planning page and on the proofreading. And I strongly disagree with that. I think the planning part aspect and the proofreading aspect are critical. We can't cut those out just because we have less time. In fact, I think the opposite. The more that we spend, not that I would allocate so much more time to planning, but the more clear that our planning and outline page can be, the faster and better we can write our essay. So just some more strategies to be reviewing. Now, what are the major differences in the math? Clearly, the biggest thing that everyone notices is it's a lot faster. But what I want to reassure parents and students with is that the questions are easier. In no way, shape, or form do I think that students could be solving the former Hunter math questions in under a minute each. Maybe some of them, but most of them were at least a couple of minutes of problem. So here, the questions are easier. They have less steps. There's less tricks. They're more straightforward. What the question is asking is what the question is asking. Now, the former Hunter questions, we would always look for tricks. We would look for small details that tell us that we're actually looking for something different or solving something else or searching for a pattern for a long time. That's no longer the case here, which should be a bit of a relief. But what that also means is that students must rely on the process of elimination to speed it up. Whereas in the former Hunter test, I often told students you can pretty much ignore the answer choices because you have to go, for many questions, through multiple steps to get to that answer. So those answer choices don't really help you if you have to be 4 steps ahead. But here, since most of them are not multi-step questions and relatively straightforward, you can use the answer choices. So I'm trying to help students shift their mindset into how can I use my answer choices to help me here, which is very effective on this style of math. That was not the case on the prior math. I will also show in some of our sample questions that it's very effective to estimate at times. Some of the questions can be solved just estimating things without having to go through the math, and that's a very effective way to cut down on time. The questions here also do vary a lot in difficulty. Some of them, you can look at them and just know the answer without doing any math and solve it in 10 seconds. Some of them are more similar to the traditional math questions that could take 2 or 3 minutes to solve each. But they all have the same value. And so there's a little bit more of organizing your time and keeping track of where you are. So you can have, for example, 4 or 5 questions in a row that are pretty tricky that require you to spend 2 or 3 minutes on each one. And that could feel like a huge setback because it feels like you're not on time. But then those questions could be followed up with 4 or 5 questions that took you 10 seconds to solve. And so you're back on track. And so it's a little bit tricky in that sense to how do I manage my time? How do I know if I'm on track? So my recommendation for that is usually to check where you're at, or use your stopwatch or whatever you're using to keep track of time every 10 or 15 minutes or so, just to make sure you're in the right pace. Because some of them will be short, some of them will be long, but at the end of the day, they all have the same value. Now, some students have tried or have taken the approach of skipping around and saying, okay, let me do all the quick, easy questions first and then the hard questions. That could work. I'm not opposed to that option. My concern with it is bubbling things on your answer sheet, skipping around and losing pages or questions. There's a certain degree of organization and carefulness that you have to really focus on to be able to do that effectively, which under the pressures of a task, students don't always do. So I don't encourage skipping around. I think that based on the prep that students have been doing for the last months or however long they've been prepping, they should be able to solve all these questions. So the fact that some of them take longer, I wouldn't skip them. I have the confidence that they have the skills and ability to solve them. The last thing on the math section here is that they're unlikely to have a lot of time to check. Because it's so much faster pace, they may be able to flag a couple of questions if they have time at the end, But because we're only at a little bit over a minute a question, they won't have a lot of time to really go back and check. So as you go through the questions, go with your gut, choose the best answer or the closest answer. Flag it for if you have time, but bubble something in right away. Don't leave that for yourself at the very end. All right. Any questions on that? You're welcome to ask questions in the chat. I will address them. In the meantime, I'll keep going. So here is the graph that shows some of the similarities and differences. You may have seen this before if you attended the prior webinar, but these are some of the topic areas that are tested. As you may notice, a lot of it is similar. So all of the prep that students have been doing has been helpful. I know there was a lot of worry in the beginning when the test shifted that everything students have been doing is no longer applicable, but that's not the case. The skills that they learned, the topics that they have covered, that's all staying. A couple of things that I do want to point out that I think are major differences is there's a lot greater focus on data and tables. Now, I don't recall seeing a ton of data and tables on the old Hunter math, but it is something that we do see very frequently on the new math. And a lot of it is just being able to read the graph or the table or the chart, which is not a difficult skill if you are familiar with this type of graph or chart. And so for students, it may primarily take a little bit of familiarization with the way that different data is presented to them, but it's not in the sense harder where they have to memorize new formulas or kind of learn new topics altogether. Just understanding, like, for example, what a trend line is would be something that might be new. And the other major thing that we see is the logic and reasoning. So all of those pattern recognition and logic games that we played on the old Hunter math is pretty much out. Now there's some questions that I think do very closely resemble old Hunter math, but a lot of those challenging logic and pattern questions are out. So I hope that that's a relief for students because that is something that most students struggled with. Now on to some of the major differences. I wanted to highlight quantitative comparisons, formal algebra, and data interpretations. So quantitative comparisons, I'll show you a couple of examples of what that looks like a little bit later on. It's just a different style of multiple choice. It's not a question followed by A, B, C, D. It requires you to, it's more like a short answer question, which requires you to compare if two values are the same, different, if one is bigger, the other is bigger, if they're the same, or if you can't discern the relationship. So we'll take a look at some of those examples a little bit later. Another aspect that I notice more commonly on the ISEE is formal algebra. Now what that means is students will get a lot more equation-based X's and Y's, and that is something that they should be familiar with from the old Hunter, but something I would really focus on to refine and practice for the new questions. And lastly, kind of what we already talked about with the data and tables, this data interpretation is a much more commonly tested question. So on to a couple of our sample questions. This is where I said if you want to work alongside us, pen and paper would be really great. And if your child is here with us, I encourage them to take a stab at some of these questions too. So this question asks, the graph shows the total rainfall for 6 months last year in city C. According to the graph, what is the mean monthly rainfall? So this is an example of the data and graph questions that I was referring to that are a little bit more common here. So this is a bar graph reflecting months rainfall over a couple of months. And so it's asking students to read this graph. We have to understand, how do we read a bar graph? What do the values mean? How do we interpret them? And then it's asking us to find the mean. Now the mean, as we know, is just the average, so students should know how to solve that part, but mostly here it's understanding the data. And it does require looking a little bit more carefully at some of these values. So I'll give you guys a couple seconds to take a look, and then I will show the answer. All right. If you've had a chance to take a look at it, here's our answer. So one thing I did, and so to the question that was posed in the chat earlier, how do we work through problems on the math? You will have enough space and or scrap paper to work all over this. So this was my markup right on the page where the question is, and you do have space around it to show your work. So what I first did was I annotated each of the bar graphs with their values. So for some of them, it required taking a closer look because, for example, some of them were in between two numbers, so they were 7.5 and 9.5. So part of this question was just reading the graph carefully. And then I noted that mean means average, and so all we had to do was take an average of those numbers. Pretty simple. It takes a bit of time to do the addition. So one of the strategies that I would have recommended for students here is to use effective strategies for adding. So like, for example, and this might be obvious, some students do this inherently, but some don't. Uh, let's see if I can annotate this. One thing I would have done here, for example, would be add 4 and 6 to make 10, and then I would add the other whole numbers, 10 and 8, to make 18, so that 10 and 18, that's already 28, and then you can add the two numbers that end in 0.5 to make another whole number. So it just shortens by a couple of seconds the addition, and then you have to do the division, and you'll get 7.5. Now, not a long question, should be quick if you can work efficiently and figure out what the question is asking. Let's say you are stuck on time. Another approach here is to look at the answer choices, right? Which is what I kind of mentioned before about how we can use our answer choices to our advantage here. Since the max here is 10 and there's clearly a lot of numbers that are well below 10, answer choices C and D were pretty unreasonable in this sense. So I can cross those out and say I'm really stuck on time. At least I'm down to a 50-50, which is already a big bonus. And so something that I try to show my students is that if you are taking this test, let's say you're in a practice test and you really got stuck on one question, you're at the end, you only have a couple of minutes left for a couple of questions, at least narrow down to 50-50, or cross out answers that seem unreasonable, and you will possibly get a couple of extra points if you're lucky. Okay. Some questions. So the next one here is number 6. Which number is the closest to the square root of 150? And I use this one to show that some questions, they don't require calculations. They don't require to write anything, do any math. Students should already know all of the roots up to about 15 or 20. I would say 15 is a safe place to be. Memorizing up to 20 would be great. You don't need to memorize beyond that, but the rest, those should be memorized. Like perfect recall, 12, 144, 11, 121, and so forth. So here you just need to estimate. This is an example of a question that can take under 10 seconds, especially because this test makes it a little bit easier in that your answer choices aren't necessarily so close together. They do make the estimating here a little bit easier. So if you haven't done it already, we know 12 by 12 is 144, but we know 20 by 20, the next biggest one, is already 400. So that clearly is too far, so the answer is B. My goal or hope is that students can answer this question just by looking at it. You don't need to write anything down here. And I have seen, I would say one of these questions at least per test. So square roots, common topic, but definitely plenty more questions that don't require calculations like this one. Another graph question. So some of them, like the first bar graph we saw, very easy, but they do get a little bit harder. So question 9, for example, says the graph shows the relationship between the number of items ordered and the total cost of the order. Using the line of best fit, what is the average cost of a single item when 60 items are ordered? So a couple of things we have to figure out. Do I know what the line of best fit is? One common mistake that students can make is say, okay, the question's asking me about when 60 items are ordered. I'll go to where it says 60 and I'll find where the dot is. But that's not the line of best fit. The line of best fit here is, well, quite literally, the only line on this graph. So it's the line that kind of goes through the majority of the points or the average. So that might be a new concept that students haven't learned that they will need to review for this test. But as I mentioned, it's a simple one. Once they learn it and review it a couple times, they know it. It's not a new formula you have to test out. It's not a new topic you've never seen. It's just some new terminology that they have to become familiar with. And now, okay, we go to 60. We see the line is about here. We go across, it's at 450. Okay, my answer is D, right? No. That one was there, that answer choice was placed there as a trick. So though I say that this test has far less multi-step questions, there are some that require you to go a little beyond what's directly in front of you, like we see here. So since the question's asking what is the average cost of a single item, you would have to do 450 divided by 60 items. Because they're asking you cost per item. Now, here's the other thing that I wanted to point out and why I like this question. They do show you what a potential trick answer is looking like, and you can narrow that down right away. But look at the other 3 answers. They go into decimals, which is telling us that when we divide 450 by 60, it's not going to be a whole number. So do I need to divide the whole thing? No. And this is a good example of where I would say cut corners and estimate. Because the first number is for A, B, and C is 6, 7, 8. They're all different, which really works in my favor. Why? Because when I do 450 divided by 60, which is, don't forget, the same thing as doing 45 divided by 6, shorten that for yourself, I only need to figure out what the first number is. Because once I figure out the first number, the other 2 answer choices fall off. So this is another way, shorten, cut corners, estimate. I don't need to do all the math. I just need to do enough to get the answer. And if you did calculate that, the answer here is B, 750. Now, the next topic here is algebra. So this is one where I would really encourage students to show their work. Some students love to do algebra in their head. I encourage them on this test not to, because it's a little bit more straightforward. You can write it out. You could probably do this in your head if you wanted to, but I would recommend writing it out. So if you get a chance, here's my solution. Now, I encourage you, does anyone see another thing I could have done? Is there another possible solution that's faster than my solution? If you're looking at this carefully, there is. Now, first, I'll walk you through my solution, which was isolating for y, and then plugging y back into the new solution. So I can plug back in y. But if I'm careful and I look at the question, I recognize there's a pattern, and some of you have actually caught on to it already. The 4y minus 1 and the 8y minus 2, well, 8y minus 2 is just double 4y minus 1. So I can solve this question by just multiplying both sides of the equation by 2. So all I actually needed to do here, and turn this question to being 10 seconds, is multiply 7 by 2, just by recognizing that. That's very common here. Um, so whichever way you do it, your answer is still 14. Nothing wrong with the original way I did it. That's why I have it up on the board. It's straightforward, it's foolproof. It's still not going to take a long time. But in a pinch and in a time crunch, I do like students to try to find the shorter versions and practice those shortcuts so that they can be ready for that on the test. All right, and this is an example of the kind of algebra they'll be doing, right? It's not in some fancy word problem. There aren't, characters and things going around. It's just, here's the equation, solve for whatever it is that they're looking for. So, yeah, any questions? Right. Some of you guys in the chat were able to figure out this trick, so great job there. Yeah. So here is where we are um, up to the quantitative comparisons. So these questions are examples of the quantitative comparisons that you will see on the test. Notice, these are two of the questions. They don't have answer choices, which means you actually have to solve the problems directly. Now, this is a good, this might seem scary to not have answer choices because the old Hunter test had answer choices, but I remember teaching all my students, don't rely on answer choices, right? Always solve the question forward. And so this is where skills like that really come to fruition, become valuable, because you don't have answer choices to rely on. You have to go through it. So if anyone wants to take a stab at 21 and 22, for quantitative comparisons, what we are solving for is to determine which side of the equation is bigger or smaller. So if your answer is A, that means column A is bigger. If your answer is B, it means column B is bigger. If the answer is C, that means the two are the same. And if the answer is D, that means that you don't have enough information to solve this. I do always caveat, and I tell my students, D is a very rare answer choice. If you're not understanding the question or if you're having a hard time, do not default to putting D as the answer. D will be the answer maybe 2 times on the test. I don't think I've seen it more than 3 or 4 times total. So try your best. Either write out the questions or guess. So thank you all for the participation in the chat. Most of you are actually getting this right, so great job. To go through them super quickly since you guys are doing so well. So for 21, column A says root 9 plus 16. So how do we do this? We have to imagine there's imaginary parentheses, and we do what's inside first. So 9 plus 16, 25. Root 25 is 5. But on the right-hand side, we have to do them separately. And again, like I said, part of the skill is memorizing all of your roots up to 15 or 20. So comes in very handy, although these are very easy or low numbers. So root 9 is 3, root 16 is 4, 3 plus 4 is 7. 7 is bigger than 5. Column B is bigger than column A. B is our answer. So for everyone who said that 21 was B, you got it. Hopefully, that question took you less than 1 minute to do. That would be the goal here. Now, 22. I like this question a lot as well because there's also a shortcut. Now, they're asking us -3 to the 4th power or parentheses -3 to the 4th power, which obviously when you say it out loud sounds the same, but the parentheses make all the difference. So one thing you can do is solve the question. You can do 3 times 3 times 3 times 3. And to the 4th power and then put a negative in front of it. Or you can, do -3 times -3 times -3 4 times and so forth. However, there's a faster way. What I can recognize is that looking at column B, if I'm going to multiply a negative number by a negative number an even amount of times, what is my answer always going to be? It's always going to be positive. And on column A, when I put a negative number in front of anything to any power, well, it's always going to be negative. So while this test wouldn't give you super hard or tricky numbers, of course, like I said, you could write this out. Doing 3 to the 4th power isn't going to take you a lot of time. But I tell students to practice, well, what if it said negative 3 to the 9th power? Now, you don't want to sit there and do that math. So using our strategy of knowing what's going to be positive and what's going to be negative, turn this into a 10-second question, right? So my goal is that the way I do it, that students can do it, that I look at it and say, that's going to be positive, that's going to be negative, column B is bigger than column A in any circumstance. So some of you have caught on to that in the chat, so great job. So I hope that that was helpful. As always, let us know of any questions. Okay, now this has been a question for many students and something that I cannot fully explain today, but I hope that students will be going over in their classes. And if not, I encourage students to seek out supplemental help for this, because this is a topic that truly is tested on this version of the exam that was not on the last version of the exam. Graphs and slopes. Luckily, I wrote here, there are very, very few formulas. There's actually, I wrote out, there's really only 2 formulas you need to know. Y equals mx plus b, and that slope is the change in y over change in x. Now, some of you, and I see you guys are writing this in the chat, that you have no idea what this means. And that's okay. From just looking at it and not having looked at graphs much or slope, this could feel like a foreign language. And that's totally fine, because it gets a lot easier. Once you learn graphs and slopes, it does make sense, but it is a little bit too much to condense into this one webinar. I hope that it is something that is being taught in your 100 classes, and I can pretty much assure you that it is a lesson that can be taught within an hour or so. So this is something I just wanted to flag as being new. For those of you who did attempt this question, the answer was in fact A. So just to preview, and I don't want to overwhelm anyone who hasn't reviewed this material yet, that the slope of a line is really, in simple terms, how steep it is. So if it's, and it can be positive if it's going upwards, or it could be negative if it's going downwards. And so you can find the slope of a line between 2 points. Think about if you graph them, you can find the length, how you could find the length, but you could also find the slope of how fast it rises or decreases. And you can always find it from an equation. And so y equals mx plus b is a very standard formula that we use to graph an equation of a line, where y and x are the coordinates, and m is our slope, and b is the y-intercept, or where the line hits x equals 0. So that could sound like a bunch of mumbo jumbo at this point, and that's okay. I'm sure you will cover this in class, but those of you who do know a little bit about slope, that's kind of the short version. So for those of you who don't know, I just want to reassure you that though it sounds unfamiliar now, it's a rather quick lesson. So let me see a couple of questions in the chat about this. So one option is you can potentially draw both of these. I think that would be too much of a time trap and really hard to do accurately, because you would need to have 2 equal coordinate planes with the numbers written out. That could be very subjective and hard to tell. To get the slope of A, this would be more of an algebra question, actually, of just reworking the equation that you're given into y equals something. So what I would do is isolate for y in that question. Yes, and b in the equation is the y-intercept, so it's what y is when x equals 0. So if you think of a coordinate plane that has like your x and y axis, it's where it hits it on that vertical line, and that could be positive or negative. I don't want to dwell too much on this because you will cover it in class, but just as a brief overview and the kinds of questions you can expect with it. This test will only deal with lines in the format of y equals mx plus b. If you are looking to external sources for this kind of work, you will see that it gets a lot more complicated. Lines get squiggly, they turn into circles, they turn into arcs, and all of these other things. So really focus on just y equals mx plus b and just the slope, both in algebra and on a graph. And that's all you will need to know. Okay, so I'm going to move on from this.
Good question. So
Please direct all your questions to the chat, and I will address them there, just so we're not all speaking over each other.
Okay.
Okay. So sorry, I think a couple of people also wanted to chime in on this. The answer, just to repeat that for those of you who solved it, the answer was A. And remember, you're just solving for the slope, which is okay. Moving on from there, another type of question that I see frequently on this new math is probability. Now, you've covered probably some of probability on the old Hunter test. However, this one will have probably a couple more questions than you might be used to. Now, I do know that some students on the old Hunter test said, probability, I'm just skipping that question. And that would be okay if it was only one question. But since we have a couple more here, it's kind of hard to avoid at this point. Luckily, they don't go really too in depth, and I think probability really gets summed into two easy pools: and, or, and multiplication or addition. So I would say that the probability here is easier if you did study for it for the old Hunter test, but if you tried to avoid it for as long as possible, it's no longer avoidable. So here we have a spinner divided into 8 equal parts, and we're comparing, it says, column A, the probability of an odd number. So that's 1, 3, 5, or 7, which means that the probability is 4 out of 8, or 1/2. And then B says, for any time the spinner is spun, the probability of spinning a number less than 5. Now keep in mind the probability of a number less than 5 does not include 5 itself, so that would be 1, 2, 3, or 4, which is also 4 out of 8, or 1 out of 2. So for those of you in the chat who guessed C, you're totally right. Yeah, so both of them are a half. Now, like I said, a rather easy probability question. They're not really asking you to combine too much. There will be probability questions that can ask you to combine. So for one example that I can give is something like the probability that on your first spin you get an odd number, and on your second spin you get a 7. So how would you combine those two probabilities? Compare that to another combination. Which, remember, combining probabilities is not hard. You just have to recognize if you're multiplying them or adding them, and that is it. Okay. Another type of question, just to wrap up, a couple of more sample questions here that may differ from what you would have seen on the former Hunter test. So diagrams, we would be familiar with these. And different symbols, also you should be familiar with these from the old Hunter test. So question 5 here, use the diagram of the balance scale to answer the question. In the figure shown, if 5 circles equals 2 triangles, and 1 triangle is 15, what is the value of the circle? Now, at the end of the day, this is actually just an algebra question, but I think it would require or be helpful to write things down and move your equations around. I don't think it's something that you can do in your head, but go ahead, take a stab at it. You guys are doing great. And I really appreciate everyone's participation in this. I see someone wrote, yeah, some of you guys are giving explanations. Very, very helpful. Right, so if one triangle is 15, two triangles is 30, and if 5 circles is also 30, then 30 divided by 5 is 6. The value of the circle is 6. That's it. This is something that I could say might be worded a little bit funny or in kind of a new type of wording that you might not be familiar with. So you can also use your answer choices to help you here of what would make sense. So for example, 30 would be too big, and you can plug numbers in if in doubt. But when you do the math, as many of you are doing in the chat right now, which I really appreciate, it turns out to really be a 30-second question. Right. And this is actually the last question I have prepared. Which is equivalent to the expression of 60 times 48 plus 52 divided by 3? So why I like this question, it's another example of an estimating question. You can do this really efficiently very quickly if you have the right approach. 48 plus 52. They kind of give us actually pretty nice numbers here because 48 plus 52 is 100. Then 60 divided by 3 is 20. 20 times 100 is B, 2000. Now that's actually doing the math. So for those of you who guessed B, you're absolutely right. I guess you probably didn't really need to estimate here. You didn't need to estimate here, but I also would say that if I just did the 48 plus 52 and I knew that was 100, the rest of these numbers, they're ending in 0. They're I don't want to say clean numbers, but they're going to divide evenly. So even if I, for some reason, was running out of time and I didn't want to do the division, think critically about what could possibly be the answer. We know off the bat 6,000 is too high. So I'm dividing it by 3. That wouldn't make any sense. And then A and C are both, they both end in 12, 932, right? We know that's not the case here. So the only kind of number that works here is is B, 2000 for question 11, for those of you who answered that. Okay. That's all I got. So please let me know if there's any questions here other than that slope question. That seems to be a focus. Like I said, I don't want to spend too much time talking about it because it's hard to give a general overview of it. You would have to really explain slope, graphing, and all of that, and that's something that students will cover in class. But those of you who solved it, to repeat, the answer was A. The slope in the equation is m. And to find the slope between 2 points, you use the change in y over change in x. So like I mentioned, that is, the slope between 2 points is a change in y and change in x. So these are the two only equations that you need to know. Slope is sometimes easier to understand visually. However, I've noticed on this test, they don't always give you a graph. So you can't, like I said before, it's not efficient to draw a graph every time you're solving these questions. And even if you have the time, your graphs are often don't work, or often inaccurate. So that's why it doesn't work. Okay, let me take this out of slideshow view since you guys want to see how it works for A. And I'll do it over here. So for column A, it's probably easier than you think. It's actually just an algebra question. 4x minus 2y equals 10. Now, again, if I know that the formula for the slope is y equals mx plus b, all I want to do is isolate for y. So I would do 4x equals 10 plus 2y. I'll do 4x minus 10 is 2y. And then I'll divide both sides by 2, and I'm just flipping them here, is 2x minus 5. So m, or the slope, is 2. That's it. So here, this was really just an algebra question. Yeah. X and y are always coordinates. M is always the slope. B is always the y-intercept. I hope that was helpful. B is an example of a question. So for those of you who like the visual approach, you can draw it. But I'm always very cautious because it could look messy. So we have 4, 4, 2, 8. Now, if you do draw it, this question, I'll caveat that fine, you could have drawn it, because you'll immediately see that the slope is negative here because it's facing downwards. So you know that A has to be bigger just because it's positive. Now, not always the case, and not always this easy. So I always would say, okay, you have to actually do the math and do the difference in the change in y over change in x. All right. Any other questions? Let's see, there was some confusion about this. What's m? M is the slope. In this case, we only are comparing the slope, so we don't need to know the y-intercept, but yes, the y-intercept here would be -5, which doesn't matter. How did I get from the previous step to 2? So in the previous step over here, where y equals 2x plus 5, this is, again, and this is why I don't want to confuse anyone, this is the equation of a line. This is the format for the equation of a line. Y, and I have it over here, y equals mx plus b, where m is the slope and it's the number next to the x, and b is what's being added or taken away from the x, and that's to the right. So m being 2 is just the fancy way of me saying that the slope is 2, because it's the number next to the x. How do I know that that it's negative or positive? Well, if I know that the m is the slope, if it's positive, it's positive. If it's negative, it's negative. That's kind of, that would be really the giveaway. When I said for B, how I knew it was negative is from our drawing, which some of you recommended in the beginning. If I wrote out, this would be my 4, 4, and this was my 2, 8. Again, very rudimentary drawing here, so I apologize for that. You can see that its slope is downwards. And this is a little bit hard to tell sometimes, but this is down. That's negative. I'll draw a little negative sign here. And this is positive. And as you'll learn, slopes can be very negative, slopes can be very positive, but they can also be a little bit negative or a little bit positive, or the slope can be 0 if it's just a horizontal line. So hope that is helpful for an explanation on slopes. I'm happy to answer any other questions. I don't want to overwhelm anyone about these slopes because you will cover them in class. I don't think this is enough information for you to know about it. I also think this is not a good first kind of impression to it, because I would hope that you would learn a little bit more about coordinate graphs, points, and how things work before you get onto this. So that's what I have for today. Thank you for tuning in. I will stick around for a couple of minutes for any questions. Otherwise, this webinar is done at 6. So. Thank you so much. Happy to answer any questions, not just about math, but about the Hunter test or Hunter altogether. I was a graduate of Hunter. I've been tutoring at Kweller for the Hunter test for many, many years now. So I'm very excited about it and wish everyone luck.
Hello.
I would also just recommend any questions be directed to the chat just so no one's speaking over each other. That's sort of the purpose of the webinar. So thank you for that. And thank you for everyone's participation today. It was very helpful to see you all follow along. I hope you can apply this to your classwork and your homework and your practice tests. Yes, the recordings will be available later. I believe Francis will post them to the YouTube channel and likely send them out as well. Thank you guys. My name is, I'll also put on the board, my name is Dasha. I'm one of the tutors here. And I'll include my email in case anyone wants to reach out or has any questions. I'll put it over here. I'm also happy to answer questions about the school or anything else. It's Dasha Hunter Fordham. So if anyone has any other questions, feel free to reach out. Any other tips for Hunter? I mean, I have tons and tons of tips, so it's obviously hard to sum them up or make it simple, but really I would say take good notes, review your strategies for both reading and math, practice your timing. I mean, this is a tough test. I took it so many years ago, but I still think I'm still so impressed with my students for sitting down for 3 hours and taking a test. That is hard. Just the stamina it takes to really get through it under the time pressure. So I would practice the stamina, the timing, the organization, right? When I take practice tests or when I, teach students to take practice tests, my tests are written up all over. I don't think it wastes my time. I think it's effective for me to do annotations next to my passages, for me to underline, for me to make mental notes for myself. For the math, I mean, I showed you guys here, I write out every question. So just write out as much as possible is my advice. If you find that it's messing you up or taking away your time and it's not effective, don't do it, right? Everyone has an individual approach. And I think my biggest tip, I guess, would be to try different approaches until you see what works for you. Because I used to, prescribe certain things and say you must underline or you must do this. And when I see that it's messing students up, it's just not effective. So try different things, and only after you try, decide what works for you. So that's my advice. And happy to, of course, answer any more specific questions about different types of questions and so forth. In terms of the next webinar, I'm hoping that we can do something maybe after the Christmas break in the beginning of January to review this again, but also happy to answer any questions along the way. Sorry, I don't know if you can see my email, but also happy to answer questions by email or you